Hello, in this video I'm going to show you how to use a visual model to factor polynomials. So factoring, to start off with, really means taking something that is an expression or value and breaking it into components that could be multiplied together to give that original expression. So for example, if you started with a value of 12, you could factor that into 3 times 4. In the case of a polynomial, you're starting with something that has variables in it, and you're breaking it into a multiplication of 2 other expressions that also have variables in them. So we're going to start with an example of x squared plus 6x plus 9. So in this method, I'm using color to represent the sign of various values. So you can see up here in the corner I've drawn a little diagram to help remember. Anytime that I have 2 of the same color that are going to be intersecting in my model, that indicates a positive value, whether those are 2 of the blue that I'm using or 2 of the red. If I have 2 colors that are not the same that are intersecting, that's going to generate a negative value or represent a negative value. So in this expression, x squared plus 6x plus 9, all of the terms are positive. So everything that I do is going to be in blue in this first one. For the x squared, it doesn't matter how large I make the square, I'm just going to randomly make a little square. So that's my first term. And then I'm going to skip over that middle term and go to the 9. 9 is a constant. That's a number that I can count. So I'm going to think about how could I represent 9 on a grid. And for me, right away, I see 9 as a square that is 3 by 3. Like this. Okay. Now from that constant term, if I continue each of those lines of my grid across and up, it completes a shape here. I'm also going to continue this one from my square. It makes a square of its own. So because that is the case, and you can see I've got 1, 2, 3, 4, 5, 6 of the little bars, that's that term in the middle that we skipped initially. So what I've just determined with this visual model is that x squared plus 6x plus 9 is a square itself that can be factored. So this x squared in here, the dimension of one side of this little square that I drew, technically it's 2 because I chose to make it that size, but I'm going to just write it as x because I could have drawn it any size. And the side length of a square is always the square root of its area. Each of these bars is 1x in length. And then we've got this 3 by 3. And they were both positives. So the factored form of x squared plus 6x plus 9 is x plus 3 times x plus 3. If it isn't possible to create a rectangle or a square with the components that you've been given, then it means that your trinomial or binomial is not factorable. Let's try another one. Okay, x squared plus 7x plus 12 this time. So again, I'm just going to use a little square for the x squared because I don't want to take up the whole page. But it doesn't matter. It's a variable. It could be a much larger box there. So that's a square that measures x by x. all positive values, so I'm going to continue using blue for this model. So now I've got 12. 12 can be broken up in a couple of different ways, so I've got to think about that. If I were to do 3 by 4 here as my 12, the bars that I would have filling in, I would have 4 bars across the top, and I would end up with 3 down the side, and that is going to work. It's going to make 7. So my 12 down here, I'm filling in the inside of that grid because I actually know that 12 is a number that's countable. Okay, and then I'm just extending those lines. So I've got x squared up in the corner here. I've got my 12 units on the bottom right. And then the bars that are left, I've got 1, 2, 3, 4, 5, 6, 7. So that is my trinomial that's been represented. It makes a nice grid. It makes a rectangle. Therefore, it is factorable. And I've got 4 bars across the top. And they're all blue, so that's x plus 4. I've got 3 bars coming down the left-hand side, so that's x plus 3. So my factors are x plus 4, x plus 3. Okay, we're going to try another one. So I mentioned earlier that 12 is a number that can be broken up in several different ways. It can be factored in more than one way. It's quite rich in that sense because it can be divided by 2 and 3 and 4 and 6. So I've got a new trinomial here that still has 12 as its constant value. So in terms of its initial setup, I'm still going to make a little box that represents my x squared. That's x by x. But the 12, I already know that if I make the 12 a 3 by 4, it's going to make 7 bars. So that's not going to work. I need 8 bars. So I've got to think about what is it that, how can I break up a 12 that's going to result in 8 bars instead of 7? And 2 by 6 will accomplish that. So here's my 2 by 6. So that's still 12 little squares. And when I extend each of those grid lines to make my rectangle, I've got 6 bars along the top and 2 bars on the left. That's plus 2 plus 6. So my factored form is x plus 2, x plus 6. Okay, let's look at another one. Okay, so again, x squared is my first term. I'm using leading coefficient of 1 for all of these examples. So my x squared is just a little square. That is x by x. My 6. I have to think about how I could break that up. I could break it up into 1 times 6. It should come out like this. Or I could break it into 2 by 3. And 2 by 3 is the one we want in this case. 1, 2, 3, 4, 5, 6. And then extend each of the lines out. And that gives me 5 bars. So the dimensions of this rectangle are x plus 3 and x plus 2. In the next video, we will look at how to do examples of factoring using the visual model, including negative values.